Welcome to Raw History. Here, we cut through romanticization and speculation to show you, well, the unfiltered reality of human history. The ancient Romans developed one of history's most sophisticated heating systems, the Hypocaust. A hypocaust is a system of central heating in a building that produces and circulates hot air below the floor of a room, and may also warm the walls with a series of pipes through which the hot air passes. This air can warm the upper floors as well. The word actually derives from ancient Greek hupó, meaning under, and kaustós, meaning burnt. The earliest reference to such a system suggests that the Temple of Ephesus in 350 BC was heated in this manner, although Vitruvius attributes its invention to Sergius Orata around 80 BC. Hypocausts were used for heating hot baths and other public buildings in ancient Rome. They were also used in private homes where it was considered proper and necessary by the wealthier merchant class for their villas throughout the Roman Empire. The ruins of Roman hippocausts have been found throughout Europe, in Italy, England, Spain, France, Switzerland, and Germany, and in Africa as well. This widespread adoption demonstrated the system's effectiveness and the Romans' commitment to engineering comfort, even in cold climates far from the Mediterranean heartland. The ceiling of the hypocaust was raised above the ground by pillars, called Pilae stacks, supporting a layer of tiles, followed by a layer of concrete, then the floor tiles of the rooms above. Hot air and smoke from the furnace would circulate through this enclosed area, and then up through clay or tile flues in the walls of the rooms above to outlets in the roof, thereby heating the floors and walls of the rooms above. These tile flues were referred to as caliducts. The suspended floor acted as a thermal mass, absorbing and radiating heat, ensuring a comfortable temperature within the rooms. The usual construction of a basement hypocaust consisted of a layer of tiles laid continuously in a bed of concrete for the bottom surface. Piers, approximately 8 inches or 20 centimeters square and about 2 feet apart, were used as the supports for the hypocaust's internal space. The floor above was made of concrete or of large square tiles supporting a bed of concrete, on which the finished floor of marble or mosaic tessera was laid. This careful layering ensured both structural integrity and optimal heat distribution, while maintaining airtight seals to prevent dangerous fumes from entering living spaces. The materials used in constructing the hypocaust were chosen primarily for their thermal and structural properties, ensuring efficient heat transfer and durability. Roman builders often employed bricks made from fired clay due to their thermal mass and stability under heat exposure. These bricks were assembled to create the suspended flooring and wall structures that facilitated heat distribution throughout the space. Bricks were prevalent due to their high thermal mass, enabling them to absorb and slowly release heat, thereby maintaining consistent temperatures. In addition, volcanic stones such as tufa or pumice were favored for their lightweight nature and insulating qualities. These stones helped minimize heat loss and maintained consistent temperatures within the heated areas. Innovations in insulation materials, such as layering with non-porous plaster or ash, further enhanced the hypocaust's efficiency. Romans also experimented with insulating materials such as ash, volcanic pumice, and crushed pottery, which were placed between the heating chamber and the floor structures. These innovations helped maintain consistent temperatures and prevent the rise of excessive heat that could damage structural elements. Tiles, particularly terracotta, were also used for flooring and coverings because of their excellent heat conductivity and resistance to fire. Their smooth surfaces facilitated even heat distribution across heated spaces. Concrete, especially Roman opus caementicium, provided structural stability and contributed to thermal insulation when mixed with volcanic ash. The careful selection of materials demonstrated the Romans' sophisticated understanding of thermal properties centuries before the development of formal thermodynamics. Heat dissipates, so the warmest room in the structure was always the one directly above the furnace that fueled the hypocaust. Roman architects and builders designed their structures to optimize the use of heat. High-traffic rooms in villas or public facilities shared walls so they could both have proximity to the furnace and receive heat. The Romans positioned the rooms requiring the most heat closest to the furnace, and they could increase the temperature by adding more wood. In Roman baths, this room was called the Caldarium. The furnace was always nearest the Caldarium, which was designed to be the facility's hottest room. Channels built within the walls ensured the Caldarium received heat from all sides. The heating system could make the room reach 120 degrees Fahrenheit when operated efficiently. The chamber's humidity was also kept at close to 100%. Conversely, the tepidarium, or warm room, was designed for a continual radiating heat that was more inviting. These rooms were placed further away from the furnace and built with only one heated wall. In his book De Architectura, Vitruvius describes the construction of the hypocaust for public baths and explains how the Romans could save fuel by placing the men's hot room next to that of the women, with both rooms adjoining the tepidarium. This strategic arrangement maximized thermal efficiency by reducing the total heat generation required while ensuring all bathing spaces reached appropriate temperatures. Operating a hypocaust required significant manpower and was, well, expensive. The furnace needed constant tending to ensure a steady output of heat. Workers would increase or reduce the amount of wood added to the fire to raise or lower the temperature. They also had to continually shovel out the ashes from the furnace because too much ash could suffocate the fire. In addition, soot accumulation created a hazard because it was highly flammable. The fires consumed a lot of fuel, adding to the expense. Laboring over the furnace was taxing because the only usable wood was small twigs and branches. Operating a hypocaust was quite expensive, and only wealthy Romans could afford such a system in their homes. Building a hypocaust was also costly and required skilled engineering, as the system had to be both waterproof and airtight. It relied on slave labor and a continuous supply of wood to fuel and monitor the furnace for hours. Maintenance and repair costs could also be significant. The intensity of the labor and high costs limited hypocausts to public facilities, especially bathhouses and the large private villas of the wealthy. Most Romans could experience the comfort of such a heating system by visiting the thermae, or Roman baths, where the walls and floors radiated pleasant warmth even during winter months. The public baths thus served dual purposes: hygiene and social gathering spaces where all citizens could enjoy technological comforts that, honestly, few could afford in private homes. With the decline of the Roman Empire, the hypocaust fell into disuse in the western provinces, but not in the Eastern Roman Empire. The technology also lived on in the Eastern Roman, or Byzantine Empire, and was adopted in the hammams of the Arabs, who reintroduced the hypocaust to Western Europe when they built the Alhambra Palace in the 13th century. An evolution of the hypocaust was used in some monasteries in calefactories or warming rooms, which were heated via underground fires, as in the Roman hypocaust, but retained heat via granite stones. The first half of the 14th century, or possibly even earlier, saw the start of the practice of piling up granite stones on the top of the furnace vault to accumulate heat. Far from a simplified medieval imitation, the heat storage hypocaust represented a further stage in the development of this ancient technology. By this means, a room could be kept warm for days with just one firing of the hypocaust's furnace. This medieval innovation improved upon Roman design by adding thermal storage capacity that extended heating duration while reducing fuel consumption. Subscribe to Raw History for evidence-based explorations of ancient engineering that achieved genuine technological sophistication. And share your knowledge of historical heating systems in the comments below.